Hello everyone, welcome back to the channel. In the last video, we went through the process of creating a solvation box and populating it with a water molecule. And in this video, we are going to take the next important step in a molecular dynamics simulation, that is this ion addition. This step is all about neutralizing the charges of our protein ligand in water system by adding the appropriate counter ions. Therefore, let's dive right in. Here we will start with this ion addition tab, and the process of ion addition in itself entails two aspects. The first aspect deals with generating the TPR file, and another aspect actually adds the ions into the generated system. So we have designed this particular tab taking into these two aspects into consideration. So as per the requirement, the first section will generate the TPR file, and the second section will actually add the ions to the system. Well, now let's look at them one by one. Let us deal with the aspect of generating the TPR file. So in the first section, we need to generate the TPR file. This step will need a MDP file called as ions.mdp. So this ions.mdp file is necessarily required to process for generating the TPR. Subsequently, we would need a grow file that we have generated in our previous step, that is solvated.grow. We also need a recently updated topology file that we have generated in our previous step. So there is another feature, and I would say a useful one, with this title as max warning. This allows you to set the number of warnings GrowMax will tolerate before stopping. For now, we will keep it at 2, and we will let the name of the output TPR files with default ions.tpr name. Once everything is selected, we need to hit this generate TPR button. In background, this runs this gmx grompp command, and you can see that gmx grompp command was executed in the background. And just like that, our TPR file is now generated in the working directory, my friends. It also generates another file called as mdout.mdp, as you can see over here, mdout.mdp. When everything is successful, you would of course see that there will be a quote with GrowMax remind you, and then the quote as such. Well, now next comes the actual ion addition step, and this ion addition will be conducted with the subsequent section. So here we need to select a freshly prepared ions.tpr file. Once you select the ions.tpr file, you also need to provide the topology file, and let us keep the default name for the resulting file. Okay, so now we also have an option to adjust the ionic concentration in this field with name concentration mole per liter. By default, it stays at physiological level, but you can change it based on your system needs. Now, when we hit this add ions button, the program executes the gmx gen ion command, as you can see over here. This gen ion command has been recently executed in the background. So this step updates the console with a list of possible groups where ions can be added. In our case, the group we are interested in is the solvation segment, which is located at option number 15. Now we need to go back to our GUI and enter this 15 number over here in the solvent group index field and again hit the add ions button. As you can see, the GROMACS command has been again implemented, and this completes the ion addition process. Once the command is successfully generated, two things happens, my friend, and the two key updates is the formation of a structure file called as boxsol_ion.grow, as you can see over here, is generated, and the topology file topol.top is updated with added ions. So now again let us visualize how the newly generated boxsol_ion.grow file looks like. For that, we would try to visualize the newly created ionized file in VMD. Let us load the newly created file by going to the location where we have saved all of our data. Okay, well, now let us sort by date modified so that the recently created file will come up, and hit this open button, and once we hit this load button, the newly created file appears. Well, now let me show you where exactly the ions are replaced. For that, we would need to create a new representation wherein we would select the ions that are there in our grow file. You can do it using this selection tab in the graphics representation menu of VMD. You need to scroll down where you can find where are the ions. You need to select this ions and we will create a representation, and in drawing style we would select the van der Waal drawing method, and now you can see, my friends, in this 3D visualization window, these are all the newly added ions for charge neutralization. So this is it, my friends, and to recap, we first generated the TPR file, as you can see through this section, then added the ions to our solvated system, and finally obtain the ionized structure ready for the next step in molecular dynamics simulation. In the next video, we will move forward with energy minimization of this ionized system. So stay tuned, my friends. If you found this tutorial helpful, don't forget to like, share and subscribe to the channel for more molecular dynamics and simulation walkthrough. Thanks for watching and see you in the next video.